Hi everyone, this is Teacher Jane again, and my topic for today is about geometric sequence. And the examples that I'm going to use were lifted from the Mathematics 10 Quarter 1 module. We are already in week number 2. So this will be our goals for the day. To determine whether a sequence is geometric or not. Second is to differentiate a geometric to an arithmetic sequence. So I hope that you watch my previous video about arithmetic sequence for you to easily understand the comparison. Third is of course to solve the next term in a geometric sequence. And last would be we are going to learn how to insert geometric means in between the first and the last term of a geometric sequence. So if you really find my topic very interesting, I hope that you click subscribe and then click also the bell button so that you get to be updated with my new videos every time that I upload a new one. So let's start with so let's start with our first example of a geometric sequence. So I have here 1, 2, 4, 8, 16. If you are going to check 1 to 2, if you're saying it's arithmetic sequence, it's not because it only increased by 1. Here, it increased by 2, by 4, by 8. So this is not an arithmetic sequence, but a geometric sequence. Be particular about its pattern. So obviously, from 1, it turned into 2, into 4, into 8, into 6. So obviously, from 1, it only doubles, until the 16. So when you say it doubles, a 1, is multiplied to 2 to get the value 2. Then multiplied to 2 to get the value 4. Multiply again to 2 to get the value 8 times 2. That's why you got 16. So we have here 2, and that 2 is what we call as the common ratio, or it is the value that we multiply to the prior term to get the next term. So therefore, if you'll be asked, what do you think will be the sixth term of this geometric sequence? 1, 2, 3, 4, 5. So obviously, the sixth term would be simply 16 times 2, and that is 32. Then moving on, if you'd be asked, what would be the seventh term or a sub 7? So we just multiply 32 times 2, and that is 64. And a sub 8 would be 64 times 2, that's 128. So that's how a geometric sequence would work. That particular pattern, you have a common number that you multiply to the previous term to get the next term. Here's now our next example. So I have here 10,000, 1,000, 110, and then it turned into 1. What do you think is that number that we multiply to 10,000 to come up with 1,000? And that same number to be multiplied to 1,000. So that it will be 100, and then 10 to be multiplied to what number so that you get 1. Actually, in these last two terms, it is easier to know. So in these last two terms, we can tell that 10, is multiplied to 1 over 10. That's why we got 1. So which means, all these terms from the first term, is multiplied to 1 over 10. That's why if you notice, one of the zeros here, is already dropped. So it turned into 1,000. Go ahead, try it in your calculator. So 1,000 multiplied to 1 over 10. Again, you are going to drop one of the zeros here. So the answer is 100. So multiplied to 1 over 10. So drop again 1 0, you get 10. Then 10 multiplied to 1 over 10, you drop 1 0, and that will turn into 1. So let's try to check out what could be 1, 2, 3, 4, 5. So what should be the sixth term? So fifth term is 1 multiplied to 1 over 10. Of course, our sixth term would be 1 over 10. So what should be the seventh term? So since this is the sixth term, 1 over 10, then we multiply it to 1 over 10. Notice that the answer is 1 over 100. So our denominator is actually just adding zeros, okay? But still the numerator is 1. So what will be the eighth term? 1 over 10 times, 1 over 100 times 1 over 10. So the eighth term would be 1 over 1000. So this is again an example of a geometric sequence. But then again, this time our common ratio or the fixed number that we multiply it with the prior term is a fraction. Okay. Now it is time now to finally know the definition of a geometric sequence. So it is also known as a geometric progression. So and these are set of terms in which the next term is obtained by multiplying a fixed, okay, a fixed value, which is called a common ratio, or the variable that we use to it is the letter r, the small r. So example, now how do we get that common ratio or that fixed multiplier? Okay, so in this example, 1, 2, 4, 8, 16, let's first find out whether is this really a geometric sequence. So we are going to use this formula, okay, a sub 2 divided by a sub 1. So we are going to divide, so this is a sub 1, a sub 2, a sub 3, 4, and then your fifth term. So dividing a sub 2, so 2, then dividing it by 1, so the common ratio is 2 divided by 1 is 2. But you're not supposed to stop there. Okay, you have to check everything. So how do we check everything? Then do it again with a sub 3, okay, divided by a sub 2. So our a sub 3 is 4. Divide it by 2. The answer is 2. Now do it again with a sub 4. Divide by a sub 3, which is 8. Divide by 4, and again it's 2. And lastly is a sub 5 divided by a sub 4, which is 16 divided by 8, and you get 2. Since 2 is common, okay, to all the preceding terms, therefore our common ratio, okay, or our fixed multiplier is the value of 2. Okay, so let's move on now to telling whether the pattern is a geometric sequence or not. So let's start with the first one. So we have 3, then 9, 27, and 81. Of course, we are going to do now checking the value of r. So 9 divided by 3, so we have to check everything. 27 divided by 9, and 81 divided by 27. Okay, then we're supposed to get, okay, a fixed ratio here, a fixed value rather. 9 divided by 3 is 3. 27 divided by 9 is 3. 81, divided by 27 is 3. So our common ratio is 3. Therefore, this one is a geometric, okay, sequence. We are sure now that it's a geometric progression or geometric sequence since there's a common ratio of 3. Now let's go to letter B. So let's check again. 8 divided by 3, 13 divided by 8, and 18 divided by 13. So 8 divided by 3 is 8 over 3. Then you have 13 over 8. And then you have 18 over 13. There is no common ratio here. So our ratio is not the same. So therefore, this is not a geometric sequence. So let's check what type of sequence is this. So from 3, it turned into 5. 8 to 13, 13. So obviously, okay, 8 minus 3, okay, is adding 5. 13 minus 8 is also has a difference of 5. 18 is Okay, it says difference of 5 as well. So this is not a geometric sequence, but it is, okay, if you remember in my previous video, it's an arithmetic sequence. Okay, why? Because it has a common difference, okay, among the terms as you move along. Okay. Okay, let's now check your understanding whether you already understood how to differentiate a geometric to an arithmetic sequence. So let's start with letter A, 10, 9, 8, 7. Okay, very good. It only has a common difference, and that difference is that it is decreasing by 1. So this one is not geometric, but it is an arithmetic sequence. Okay, so it is decreasing by 1. So the second one, 5, 10, 20, 40. Okay, it's not increasing by 10. Okay, because you see 5, then 10, then 20, but it is rather doubling. Okay, so meaning it has a fixed multiplier. So there is a common R. Okay, and it doubles. So R is 2. So this one is a geometric sequence. Okay, number 3, 3, 6, 9, 12 is increasing and it has a common value that's added to it. It is increasing by 3. So we have a common difference of positive 3. So it is arithmetic. Okay. And the last one is 1/4, then 1/2, then 1, then 2. So as you can see, it is increasing and the fraction is actually doubling again. So there is a fixed multiplier of 2 and this is geometric. Okay, maybe you're wondering how did I get the ratio 2 for these fractions? So let's work backwards. So 2, so here is 2 divided by 1, okay, which is 2. Okay, and then the next one here, 1 divided by 1/2 is also 2. Next, you can actually check this. Here's your calculator. 1/2, you divide it by 1/4, okay, is also 2. So in this case, okay, we have a common ratio which has a value of 2. So we are now going to level up and learn how to solve the next terms of a geometric sequence. So there is a general rule of a geometric sequence given by a sub n, okay, is equal to a sub 1 multiplied to the common ratio raised to the power of n minus 1. So where a sub n is actually the last term, okay, a sub 1 is of course the first term, r is the common ratio or the multiplier, okay, and of course, n would be the number of terms that we want to solve. So this is the number of terms. So these are the important, okay, variables in the formula or in the rule. A sub n, last term, a sub 1, the first term, the r, common ratio, and n, which is the number of terms, so that we get to use this formula. But later on, you will realize that when solving for geometric sequences, your calculator will do a lot of benefit for you. Now, let's apply now the general rule in finding the next term of a geometric sequence by answering this problem. So it says here, what is the seventh term of the sequence 3, negative 6, 12, negative 24? But before we apply the general rule, let us first check whether is this really a geometric sequence, okay? So we are going to solve for the common ratio r, okay? So with that, we are going to work backwards. Negative 6 divided by 3. Then here, 12 divided by negative 6, then negative 24 divided by 12, so that we are going to get a common ratio. Because if not, therefore this is not a geometric sequence. So this is a value of negative 2, negative 2, negative 2. So since all the ratio is negative 2, therefore we have a confirmed geometric sequence. So the value of R, okay, is negative 2. Now let us now move on to solving the problem. What is the seventh term? So seventh term would mean you are being asked to solve for A sub 7. Okay, so that is our A sub n, or the A sub 7. Next is, since we are solving for the seventh term, therefore our n has a value of 7, meaning the number of terms, okay, that compose this sequence, okay, would entail 7 terms. So that's the value. Now our A sub 1, or the first term, is here. Okay, it is positive 3. Now, I'm going to write now our guide, the formula here. A sub n is equal to the first term. Then you multiply it with the common ratio raised to the power of n minus 1. Okay, so let us now substitute here, okay, using that formula, since we are already complete. Okay, so our A sub n is A sub 7. Would be equal to A sub 1, okay, is equal to 3. Then the common ratio here is negative 2. Then raised to the power of n, 7 minus 1. Okay, so to continue, let's simplify what is inside the parenthesis first. That would mean 3, negative 2. 7 minus 1 is 6. Okay? So, negative 2, okay, raised to the power of 6 would be negative 2 times negative 2, 4 times negative 2. Okay, let's list that down so that it means negative 2 times negative 2 times negative 2 times negative 2 times negative 2. 1, 2, 3, 4, 5. Okay, last one. Times negative 2. So this is positive 4, and the last would be positive 4. So 4 times 4 is 16. 16 times 4 is 64. Then 64 times 3. So this is 3 times positive 64. So A sub 7 would be 12, carry 1, 3 times 6 is 18. It is positive 192. So the seventh term, okay, of this geometric sequence is positive 192. So you can go ahead and check using your calculator. You just simply multiply, okay, negative 24, you multiply it with negative 2, then multiply it again with negative 2 as you move on to the seventh term, and check if the answer is 192. Okay, in our next problem, let's try. Okay, let me read the problem first. What is the 29th term? What is the 29th term of the sequence 1, negative 1, 1, negative 1, and so on? So it seems this pattern, okay, is simply an alternating pattern of either 1 then followed by negative 1. But you are being asked about the 29th. So if you are patient enough to count until the 29th term, you can do so. But this time I'm going to show you that we are going to use the formula or the general rule instead. So the general rule is A sub n is equal to the first term multiplied to R, Okay, let me erase this. Okay, multiply to r raised to n minus 1. Okay, now let's identify now, okay, the representations here. So we are solving for the 29th term. So a sub n is actually a sub 29. So n is 29. A sub 1 is the first term here. Okay, that's 1. And then r, which we haven't solved yet. So let's solve for r. Negative 1 divided by 1 is negative 1. Then here, 1 divided by negative 1 is also negative 1. Then last, negative 1 divided by 1 is also negative 1. So the common ratio here is negative 1. Then let's now apply everything listed here in the formula by simply substituting. So we are solving for a sub 29. Okay, that's our an. And then our first term, a1 is 1, multiplied to the common ratio here, negative 1, raised to the power of n, 29 minus 1. So a sub 29 is equal to 1 times negative 1 raised to the 28th power. Okay, remember that way back in grade 7, if negative 1, okay, has an exponent of an even number, it means that negative 1 will simply become what? Positive or negative 1? Okay, at least you remember that that will become positive 1 because of the even exponent. Okay, so a sub 29, okay, will be 1 times 1 is a positive 1. Okay, so that is the 29th term of this sequence. So I hope you understood, okay, how to use the general rule for the geometric sequence. But if you have other methods, like you want to use your calculator, why not? For as long as you get the same answer. Okay, let's now move on to the next one. So what is a geometric means? This is now our last goal for today. Geometric means. So in this example of sequence 1, 2, 4, 8, 16, which was my first example, the geometric means are the ones in the middle. Okay. So 2, 4, 8 are the geometric means. So what are actually geometric means? The central number in a geometric progression, so these are the central numbers, 2, 4, and 8, are also calculable as the nth root of the product of an n numbers. So simply, this pertains to the values that are in between the first term. Okay, so this is our first, and the last term. So which means we are going to deal only with geometric sequences that are finite, meaning they stop at the last term. So there's a first and the last term, and the terms in between are what we call the geometric means. So let us now solve for the geometric mean. So this activity is going to entail also using the general rule that we applied a while ago. So example, find the geometric mean between 2 and 8. Okay, first is try to understand the problem first. Find, okay, the geometric mean between 2 and 8. So meaning the geometric mean that is being asked is only one, okay, term. So step 1 is to list. Okay, same thing that we did in arithmetic mean. So we list that the first term is 2, comma, then blank, comma, then 8. So that blank there is the geometric mean, okay, that we are looking for in between 2 and 8. Okay. Now to get that missing term here, the middle term here, we are still going to use the general rule. Okay, a sub n is the first term multiplied to the common ratio, then n minus 1. Okay, but in this case, okay, it is now the ratio or the common ratio that is missing for us to get the middle term or the geometric mean. So let's identify what we have in this problem. So we already have our A1. So let's list here. Our A sub 1 is 2. Now what we are looking for is actually the second term here. And this is our A sub n or the last term. So our A sub n is 8. Okay. And then our n is you simply count how many terms are there in this sequence. 1, 2, 3. Because our a n here is actually A3. So there are 3 terms in this sequence. Now r, or the common ratio, is now the one that is being asked in the problem. So once we get r, we simply multiply r with the first term. Now let's use now the formula. A sub n, okay, we have a sub n. So we have 8 equals a1, okay, is 2. Multiplied to r, which is not known. Then raised to n minus 1. N is 3 minus 1. Okay. So moving on, 8 to r squared, because 3 minus 1 is 2, or r squared. So we have 8 equals 2r squared. Since we are solving for r, we are going to divide both by 2. So this is now eliminated. 8 divided by 2 is 4, which is equal to r squared. Now, moving on with this, remember that you get r by simply doing the reverse of r squared, which is the square root. Okay, so the square root of r squared is r, the square root of 4 is 2. So the common ratio here is a positive 2. Now, let's check whether this is right by doing substitution. Okay, sorry, rather by multiplying the common ratio to the first term. So 2 blank 8. So 2 times 2, which is the common ratio, gives you 4. 4 times 2 gives you 8. So therefore, this ratio is correct, and the geometric mean that we are looking for is actually the value 4. Okay, so that's how you find the geometric mean in between two terms. Now, let's level up with the next example. Okay, this time, the question is, insert two geometric means between 4 and negative 32. So it's indicated there that you have to insert two geometric means, okay, between 4 and negative 32. So again, step 1, okay, is to list 4, comma, blank, blank, and then negative 32. Okay, because it's indicated in the problem that you have to insert two geometric means. So therefore, we are going to identify now that this is our A1 and this is our A sub n. Okay, remember in the first problem, we need to find out the common ratio. So this is the formula. A sub 1 multiplied to r raised to n minus 1. Okay, our A sub n is negative 32. Our A sub 1, our first term is 4. Then n, is you have to count 1, 2, 3, 4. N is 4, and the common ratio is the one that's missing for us to get the next two terms. So substituting to the formula, a sub n is negative 32 equals a sub 1, 4 times r raised to n 4 minus 1. So we have 4r raised to 3. This is negative 32. Then we divide both by 4, okay, so that r remains here, r to the third power, and this is a value of negative 8. Then we do again the reverse of r to the third power, and that is, what do you think? Is it the square root? No, we are going to extract now the cube root. So the cube root of r cube is simply r. What is the cube root of negative 8? The answer is negative 2. Okay, so this is not yet the answer. That is just the common ratio. So we are going back now to the problem. 4 blank, blank, and then negative 32. So 4 times the common ratio negative 2 gives you negative 8 times negative 2, okay, is actually positive 16 times negative 2 gives you negative 32. So the geometric means, the two geometric means that we are looking for is negative 8 and 16. So that's how you solve for the geometric mean. So I hope that I was able to share with you uh, the answers or the concerns about our goals for today, and that would be to learn what is a geometric sequence and how to solve a geometric sequence or finding the terms. And of course, the last one is determining the geometric means. So if you still have questions regarding our lesson for today, please don't hesitate to comment, okay, down below. And then I'm very appreciative of that, and I'll find time to accommodate your questions, okay? And please, you can share this video to your classmates. But don't forget, I hope you have already subscribed to my YouTube channel. So with that, okay, for now, I'm going to say bye-bye, and I'm going to see you again with my next video about application of sequences. That would mean I'll be discussing geometric series and arithmetic series. Okay, bye-bye.